Look at my shirts. Brand new. I just got it. All right. Uh okay. So I have some old notes I'm going to use because I just wanted to. I'm tired of being controlled by AP when math is math. What's 2 plus 2? Does it matter what AP says about it? That's a fact, right? And today is dealing with facts of what a logarithm is. So before group 7 starts answering questions because they got picked by the almighty calculator, um, I'm going to go to what I put on my calendar. This is something I made. I don't know. I guess I could look at the YouTube video, how old it is. Um, by the way, we're doing old school notes. You know what? You're never going to get probably organized notes all nicely printed out in a perfect little thing when you go to college. You have to be able to bring a notebook and take your stuff and figure out what you're doing. Got the daughter as a freshman. She's still asking us math questions because she's in a math class right now that's similar to ours. What's she doing right now? She's doing something called matrices. Have you guys ever seen a matrix before? Not the movie. You guys don't watch movies anyway. Did anyone ever see The Matrix? Okay, nice, good. All right. But there's some people believe we live in a matrix. But anyway, we won't get into that. But matrices is her concept right now. Won't get into it. It is sad that Lockport doesn't show matrices anymore in our math curriculum, except for discrete math, I believe. But anyway, I made this video because this is what a logarithm is. All right. All it is a rearrangement of what an exponential scenario is. So here we go. I made this in years past. This double take logarithm is to an exponent that equals an answer. Okay, so isn't that true? What a logarithm is. Isn't that true? That's all an exponential scenario is. You have some base raised to some power, and that equals some answer. 2 to the third equals, what is 2 to the third equal? So 2 to the third equals 8. Okay, this is all logarithm is. Then everything changes position. 3, 2, 1, go. Of answer. I think that will exponent isolated. Okay, I'll leave that up there. Oh, it just moved a little bit. All right, but you can still see it up there. When the word log comes in, then all the positions just switch. And there is no I don't get it. You need to memorize this. This is where the positions become. So it's read log base B of answer equals exponent. But let's focus on the importance of what a logarithm does. It isolates the exponent. The exponent is all by itself now. And then I'll get into our notes after this and just play out. Okay. Goes back to where we had before. Base number raised to an exponent equals an answer. And again, all that happens. Okay, and it goes back. That's it. There's your video. All right. Again, I'm struggling in 5 years ago how to get out of that movie. Okay, interesting. A movie within a movie. Talk about the Matrix. All right, let's move my Christmas shirt up here. Okay. All right. So technically, though, when I say inverse, you say. When I say inverse, you say. Switch X and Y. Look at this. I took that scenario B to the X equals Y, and I switched X and Y. So not technically exactly, a logarithm is the inverse of an exponential scenario. Because then when I put the word log in front of this, then the positions change. Log base B of X equals Y. So again, why are logarithms the inverse of exponentials? Because I switched X and Y. So I did the inverse thing. But then in order to solve for Y again, I had to insert the word log in front of this and rearrange the positions. So I am being 100% totally honest when I say this. You just need to memorize. And those that can't memorize are the ones that get destroyed in logarithms. When we have our next quiz, Anyone that does not know where these three positions are, you will get the Lockport 50%, which means you'll get a 20, that then because you breathed and you showed up to class and took the test, you'll get a 50. All right, I'm not being mean. I'm telling you what is important. All right. And it is not something that you can say, well, I just don't get logarithms. No, you can't memorize three positions. That's what you can't do. All right. He's so mean. I don't. Anyone? Or I couldn't. I'm sorry. I couldn't. Caroline, you're learning. You're learning. All right. Okay. So there we go. We got our classic switch X and Y, and then rearrange or insert the word log so I can solve for Y again. But really just focus on what does a logarithm do? It gets the exponent all by itself. So if you remember the exponent's all by itself on one side, then what are the other? Then it's a 50-50. But it's read log base B of. So the base goes down in that little subscript. So it really is not a hard thing to memorize, is what kills me every year. So what is log? It is a mysterious algorithm. It is that rearranges the positions of an exponential equation so that the exponent is isolated, so we can really analyze what that exponent is. Okay, your names are going to be online. So who do we start with? Let's start with good old Jake from State Farm. Hey, Jake, look at that logarithm for the first time in forever. But really, what we can do on this is understand what I'm solving for, some mysterious X. And really what this is saying is 2 to what power equals 8? Because that's how I would rearrange this. This is the base. This is the exponent. This is the answer. What's the answer to that question, Jake? 3. So this logarithm is, quite frankly, 3 as an evaluation. That's what it is. Now watch what happens. You want to get nuts? Let's get nuts. Aw, Diana. See, all right away. I don't know what I'm doing. Okay, but we already did this, my silly little friend, because what is the square root? The same thing as here. I'll give you a hint. So, the root 3, that is equal to 3 to some power. And what is that power? We already did this, and we're supposed to know what square rooting means. Not to the second, because what's 3 squared? 9. That's not 9. So this is 3 to the what? Okay, remember, this is the first power, and then this is a square root. What am I supposed to do with those two? It's a what? A fraction. So what is that fraction? 1/2. Okay, so 3 to what power equals the square root of 3? That's what we're asking. What is that? What is that answer? You just told me. Yeah, but what's the answer? Is it 3 to the 1/2 or is it just 1/2? It's just 1/2. We want only the power there. Okay, now I'm going to be totally and completely honest. It ain't logarithms that kill people in the logarithm section. It is not remembering your exponent rules, because logarithms are exponents. So we forget what square root means, cube root, or 3 squared, the cube root of it, that's to the 2/3 power, or negative exponent rules. Kathleen or Kiana. Oh no. I just did a sister thing. Did I just tell you what happens with this? Yes. Okay, first of all, what's 25? 5 what? So 1 over 25, that's 1 over 5 squared. And then what does this equal? 5 to what power? Okay, so I got to get what 1 over 5 squared is equal to. Answer that question first. What's the flipping rule in exponents? What happens to the exponent? Nope. Okay, it's 5 to what power? Help her out. What does everyone say? Let's -2. Okay, so again, this is not logarithms that kill students in this stuff. It's not knowing your exponent rules, which we actually already went over. So, Kiana, 5 to what power equals 1 over 25? We just told you the answer. And what is it? 3, 2, 1, go. Huh? -2. Let's get a different group now. If it's 7 again, then it's 7 again. Here we go. Oh, 7 again, and then 2. I accidentally hit a double hit. and 2 is already fainting over here. Are you ready? All right, so let's go back to Jake. Why is that not closing? Okay, Jake, we're getting rolling here now. So 4, this is how this works, and I'm going to write this in words because this is really what it means. I'll put this in quotes now. What this means is 4 to what power or what exponent, but I'll use the word power, equals 1. What's the answer to that, Jake? You are correct. 0. Okay, nice. All right, Diana. Yeah, you didn't even see the question. She's already said, I don't know. All right, so she's typing on her calculator. I will take that calculator and throw it out the window. Because I swear to dog, 7 to what power equals 7? What is the answer? First. And she used her middle finger. I'm just kidding. It looked like it. I couldn't see from that far. It looked like it. It's the first power. All right. Group 2, are you ready? Okay, sure. All right, so that's what we got to do. Know these quotes. This is what this means. Yes. Oh, I didn't forget. Don't worry. All right, now on your no, so you get a little break, Kiana, and then the group 2 here. I do want you to write this down. You should not have your calculator out. And that's what kills people. I told you many times. Input, say it. That should have been done 100% all year long without a calculator. It's a nice day out, isn't it? It's supposed to be 50 degrees. I'm staring at someone. All right. All year long. So at this point, if we still don't know how to graph by input output, that's on your shoulders. All right. If you touch your calculator tonight, you're causing your own demise. All right. But I will say, if you did look at your calculator, you have 2 log buttons. One is just log. All right. Well, by default, that's called the logarithm or common log. Sorry. And that's log base 10. Base 10 numbers are our most popular, bases to deal with. Well, there's 2. One of the most popular. I think it's a little bit more popular than the other one. So the first one, though, it doesn't matter what the base is. This could be log base 2, 3, 4, 5, 10, log base 20. Because what's anything to the 0 power, everyone? 3, 2, 1, go. 1. All right. So here's what we have, though, here. We literally have this as here's the logarithm side. Here it is as an exponential over on this side, the exponential format. So part of your homework today is just change the exponent to a logarithm. No evaluating, just change it. All right, just so you know where the positions go. And I told you, if you don't know that, by the end when we take a quiz, you will get a 20% on the test. I can't tell you how important this is. And then why is this one log 10 1? Because 10 to the first equals 10. When I write this here, by the way, you need to know that this is, when it's invisible, a 10. There's many invisible things in math. There's x. What is x raised to? What power is this that's invisible? 1. So that 1's invisible. Square root of 4. Well, let's not make it something that works. What number is right here? What is that index right there? It's actually a 2. When it changes, then we're doing cube root. If I put a 3 or a 4th root, 2 is the accepted, standard for square rooting, square 2. So they never write it. So there's 2 invisibles in math. Now there's a 3rd. All right. And you need to know this all the time. It's not always going to be log base 10. When it changes, it'll have a number there in that position. Right. Things you need to know. And then really what this deals with is log base 10 of 10 to the y. This really is just taking care of questions like this, which we did have up in the bell work. Log base 10 of 10 to the 23rd power. It's just trying to cover questions like this. What's the answer to this? 3, 2, 1, go. 23. 10 to what power equals 10 to the 23rd? 10 to the 23rd power equals 10 to the 23rd power. So whatever is here, as long as the base equals the answer position, then that is what the answer is to that logarithm. So that's what that covers right there. Any number I put in that position for y would be the answer to that logarithm. And where do we have that? We had that in. Actually, we didn't. We didn't have that yet. I could have wrote 8 as 2 to the third. So log base 2 of 2 to the third is 3. All right, that would be an example of that. All right, but if you really just change it into an exponent, then you'll be good. Now, I do have to spend a minute on this one. And I refuse, the way the AP notes, they didn't really explain this rule. And it's not really great explainable. I'm going to do the best I can, but then this one's probably going to have to be memorized. But what I can do, I can, is I can treat this rule as an exponential scenario right now. So I have 3 positions. I have the base, I have the exponent, and I have the answer to that. Okay, so let's just focus on that for a minute. So that's an exponential, but the exponent is log x. By the way, what's the base on this logarithm? What's the base on this logarithm? 10. It's invisible. So that's what's kind of hard about seeing these notes, but they're, our old book, this is out of the green book, is trying to hammer this down. This is what you'll see a lot. Therefore, you need to know that's a 10 there. And then guess what? I'm going to bring the word log in here. What's the noise, everyone? No one wants to do it. As soon as I bring the word log in here, what goes down here? Is it 10, log x, or x? What goes down here? 3, 2, 1, go. It's 10. Actually, I should be asking the group too, but I'm going to hold off and wait till we do evaluations again. And then what goes here? So it's base goes here, base. And then what goes here? 3, 2, 1. You only have 2 choices, log x or x. 3, 2, 1, go. It's x. And if you don't have that right or didn't say it right, you're already behind. Because I literally just did the movie and it's on the calendar. You can watch it all night tonight. You can watch it 43 times. Okay, and then that equals the answer. Log of x. All right, so what did I do here? So let me just make sure that this is okay. Actually, what I was going to do is this. Sorry, that's what I forgot. We don't know this is true, so let's call this question mark. Let's call that question mark. How do I know that's x? That's what I forgot to do. So this is actually question mark here. I don't get this. How did that end up being x? All right. So that's what I kind of want to do here. All right, but then now I could take anyone off the street. I could take Lexi right here, the 8th grader, and say, "Hey, Lexi, you know what an equal sign means, right? That means these are balanced." "Yeah, Dad, I get it. Leave me alone." All right. And then, okay, Lexi, sorry, this invisible thing, this is actually a 10 here, which I just told you here. So, Lexi, just tell me, what do you think question mark would have to equal? Well, Dad, when I just look at this, there's an L here and an L here. There's an O here and an O here, a G here, a G here, a 10 here, a 10 here. And then these two are in the same position. So I would guess that question mark equals x. Do you get it? Do you understand what I'm saying? All right. So that's where that x came from. You could change this to a logarithm and actually make sense out of this. But really, after this, what it's going to be is a rule. And you're probably just going to have this memorized. You're not going to do this every time. I'm just trying to prove what actually happens here. All right. So the rule is this. I don't care what it is. What if it was 7? Well, then if it's raised to the log base 7 of x, then this answer is x. So the base has to have the same base as the logarithm for this exponent rule to actually work. I could change this to anything. I could change this to 8 as long as this is 8. Then the answer would be x. So these bases must be equal in this little rule. All right. So a lot of setup here, and this is why I wanted to do this. The AP kind of is chopped up in my mind about how they explain some stuff, and I just like the Green Book's little thing better. Remember, we actually did E. E comes from an expression that I will not write down anymore. But if you look at some previous notes we did, is approximately 2.718. The very important number in growth and decay functions. All right, because of how it's derived. You don't need to know that. You just need to know that it's important, just like pi. It does go on forever. It's a non-terminating, non-repeating decimal, so it is irrational. But because it's used so much in growth functions, it gets its own logarithm, which is called the natural logarithm. And all the natural logarithm is log base e. So the base is e, but because mathematicians are lazy, they call log base e ln. Okay, so anytime you see an ln, that is natural log, which means it's log base e. Okay, still, ln of 1 will be 0 because I don't care what the base is. Any number raised to the 0 power equals 1. Then notice what it says there, e to the 0 equals 1. And I can go to the calculator here. I can, and show you one more time where the E button is. It's actually in 2 places. Trying to find it real quick. A little out of sorts here. It's the second division. Press enter. There's E 2.718. Another position it is in is second. I don't care how long this takes. It's right there, and then I'll raise it to the first power. So it's ln. There you go. And then look at your calculator. You got a log. Log base what? Log base what? 10, not E. And then ln. Log base what? E. And then look above those second buttons, 10 to the x and e to the x. That's that's on purpose. Why those are second ln and second, because 10 to the x is the inverse of log base 10. Those are inverted formulas there. Now my big fat head is in the way of closing this. All right. Blah, blah. Just want you to know that I'm here. And that's why I keep my picture there. All right. And then ln of e equals 1 because e to the first equals e. Ln of e to the y, that's because I don't care what I raise e to. E to the 43rd power. Log base e of e to the 43rd is 43 because e to the 43rd equals e to the 43rd when I rewrite it as a exponent. Okay, that we can see that right here, e to the y equals e to the y. And then I'm not deriving this rule again, but I will say this. This is e raised to the log ln, log base e of x. So therefore that equals a big fat X, right? And again, I could prove this by base exponent answer and then rewriting it as a logarithm like I did on the previous one. So again, this rule right here, it doesn't matter what the number is. 23 raised to the log base 23 of x. That would equal x. That's the rule. This one is probably going to have to be memorized. I just have it memorized. Back in the day when I first saw this, I'm like, how do I prove this rule to my students? And it's by base exponent answer and then changing it to a logarithm. Okay, so that one we got to lock in. Well, we definitely have to log in what a logarithm is in the first place. So that's the most important thing. Okay, here we go. Allison. Now let's see if we're ready. Okay, so I got to say, evaluate the logarithms. What does this say right here? What does that say right there? What does that say? Without. Go ahead. Your finger should be burned right off your hand if you touch your calculator tonight doing your homework. Burned. All right, burned. All right, so Allison, 6 to what power equals 1? What's the answer to that? Huh? 6 to the first is 6. Darn. So 6 to what power equals 1? 0. So again, it's all about knowing your exponent rules. Definitely. All right, so that's what this says, and I'm not writing it down. To prove it, okay, base, exponent, answer, yes, this is true. So that's a discount double check. All right, but you don't have to write that second part for sure. Next, oh no, you want to get nuts? Let's get, you got to say it, nuts. Okay, what's 36? A number. What's 36? 6, come on. Okay, so then this is 6 to the second, and it's the 5th root of that. Oh, no, I'm sorry. And then this is log base 6. An unfortunate use because what does my G look like, everyone? What does my G look like? It does look like a 6. So maybe I'll put that little hook on there or whatever. Okay, next thing. What is 6? What's the square or a 6 squared and then raised to the 5th power? What is that the same thing as? Let me write this down. 6. And then this is 1 over 6 to what power? All right, and that's what I want you to know. We're not doing the flip yet. I'm doing what is the 5th root. Dang it. I wanted this really large so I know this is an exponent. So what is that as a power? Okay, squared in the 5th root. I literally just did this with Diana. 2 over 5, and that circle is not big enough at all, but that's where I wanted this at. Okay, then what's the last thing I need to do? Okay, I need to do this. This equals log, let's get that little hook on that, base 6, and then this is 6 to the what power after our last step? Okay, how do I flip? What's the rule? Negative 2 over 5. That is not a flip of 5 halves or flipping it to 5 halves. So what is the final answer then, Natalie? What is log base 6 of 6 to the negative 2/5? It's just the exponent. And you got it. And you did say that. But I just wanted to hammer that down. See, it ain't logarithms. It's knowing these exponent rules that we actually covered in a previous AP scenario. Nothing to do with logarithms. Let's get another set of students. I don't care. What time is it right now? 17. Oh, an eternity. Doesn't it feel like that in here? Ah, thanks. 4. Did you say that, Leah? Oh, there's my fat head again. You know what? Let's just get rid of me. You're gone. All right. Okay, here we go. Leah, this is very, oh, and by the way, this is the first time that I showed that. This is how it was in the book. It was just log of 1,000. All right, but then you have to know that that's log base 10 by default. 10, I don't know why this back button is not working. This is driving me nuts. Computer. 10 to what power equals 1,000? Next thing you have to know is that powers of 10. 10 to what power equals 1,000? Look at what or 10,000. I'm sorry, my bad, dog. But how many zeros do you see there, Leah? 4. So 10 to what power equals 10,000? 10 to the 4th. That's powers of 10. 10 to the 4th equals 10,000. That's how many zeros there are. There they are, 6 sipping their coffees, shooting the breeze. I just love it. I love it. I love it. Shooting the breeze. Okay, next, Allie. Ooh, just in time for Halloween. Boo. It's a ghost. What is the ghost right there? What is the what did you hear? The coffee sippers. All right. So first thing, Allie, what is 1,000? 10 to what power? We got to actually do this first, huh? And then what is the index on this radical here? There is a 2 there. All right. So then the next thing is, hopefully you can do this, but many of you, when you get your exponent rules, you'll be able to do this. You'll just right away be able to say what this is and then be able to answer the question. So I'm making you do 2 things that Natalie had to do. First of all, what does 10 to the 3rd squared become? What is it as a fraction? Switch it. It's power over index. So what is it? 3 over 2, and then what kind of power does it become because it was on the bottom? Negative. So then what's the answer of this logarithm? Good. Negative 3 over 2. It ain't logarithms. It's exponent rules that is going to kill you in this section. All right, next one. Good. I'm going to coffee sipping group. Here we go. Krista. Oh, what's ln? What's ln the same thing as? Log base what? Log base E. So what's the answer to this question then? Log base E of e to the negative 4th. E to what power equals e to the negative 4th, huh? Negative 4. So again, you just have to know ln means log base E, and then it's that rule, log ln of e to the y equals y. Ln of e to any power equals that power. Okay, Ava, oh no. Well, this is the 3rd time we've seen a question like this. Okay, so then this is ln of what? I don't know what I just did there. Ln. All right, ln of 1 over e to the 7 over 2, which is ln of e to the what? Okay, I'm not answering a question yet, but I'm saying flip what happened to that power becomes negative, and then what's the answer to this question then? What? Okay, I didn't hear the negative. There you go. So it's about your power rules, and then knowing that ln is log base e. Okay, that's it for that section. Okay, now here we go. Let's see if we could. Oh, all right, all right. Isabella, you should be able to do these next two without a problem. What's 5 raised to the log base 5 of 8? What's the answer to this question? Okay, and then what's this rule? It's this one. This one that I proved, and then this one. And then I even said this one. Okay, so let's go back to the question. What is the answer to this? It is 8. What's the next answer since you're on fire right now? Okay, what's booming? What's booming? I don't see a base there, so what's that base? 10. So it's 10 raised to the log base 10 of 14. 14. And then the last one, e raised to the ln of 1/5. What's the answer? 1/5. Why? What's ln? Log base what? So it's e raised to the log base e of a number. The answer is the number. Okay, so again, I'm being totally honest on this one. I know I derived it for you. It's something I just tried to do to try to explain it in the past. This is probably just gonna have to be flat out memorization. All right. It's a tough one. Okay, now here's the next one. I like this. Someone came up with this in our group, these kind of questions. Let's go ahead and get a group. 1, 2, 3. Nice. Oh my gosh. All right, Trinity, we'll start with you. Do an estimate. Log base 5 of 19. Now, this is when we're going to use our calculator. I'll show you how to type this on your calculator later, whenever it comes up in AP. And if it doesn't, I'm still going to show you. But what do you think the answer should be between? All right, so what's 5 to the first power? What's 5 to the second power? 25. What's 5 to the third power? Let's just keep going. Did you hear them? What'd they say? 125. So what would the power have to be between 1 and 2? It's between 1 and 2. Okay, that's what that power would have to be, because 5 to the first is 5. 5 to the second is 25. So 5 to what power equals 19? The answer would have to be between 1 and 2. All right, so what would that be? 19, what do you got? 5. 19 is a little bit closer to 25. I would guess something like 1.7-ish, probably closer to 2. But you kind of just have to say between 1 and 2. Next one, Cassidy. What's 12 to the first power? Huh? What's 12 to the second power? You know your times tables? 44. What's 12 to the third power? You have 5 seconds. 4, 3. No calculator. But don't you think 12 to the third power is going to be an awfully what kind of number? Very big number, because it'd be 144 times 12 again. So what would it be between the power? So what would the answer be between? Huh? 2 and 3. It'd be between 2 and 3 for this one. That would be the estimate. Between, I should put that there, because 12 squared is 144. 259 is larger than that, but 12 to the third is ginormous. Just understand 12 times 144 is a very large number, way larger than 259. So we still should be able to do an estimate on that. All right, and then I'll show you later how to do a calculator. All right, what I didn't do is just converting. So back in the old days, we would have a section of just converting from a logarithm to an exponent. All right, so I'm going to grab one more group. Let's say enter. What time is it? 26. All right, good. Michael, First of all, isn't 3 squared equal 9? Isn't that true? I mean, yeah, this is not a big deal. So change that to a logarithm. Okay, so I put log. What number goes down here? 3. What goes next? 9. And then what goes next? Okay, just doing that. That's it. Okay, and I don't feel like doing another one. Maybe I'll do this one RT and W. Okay, just with RT and W. Perry. So R raised to the T equals W. How is that as a logarithm? Log base what? R of what equals what? You can't say I don't get it because there is no not getting it. You just do it. All right, Nike. All right, and then the reverse. The reverse. Okay, I know you don't have these written down, so I guess kind of like that. Converting a log to an exponent. Very simple. What time is it? Sorry. Oh, we're doing great. Group number 1. Jack, how do I change log base 7 of x equals 2? So how do I change that to an exponent? Yep. Equals. And then you know what? That's how you'd solve this. What's x equal to? What's x equal to? 49. So you're going to find out when we get into the solving arena, like solving logarithms, sometimes it's just changing a logarithm to an exponent or an exponent to a log. I mean, that's a big way of solving. And I don't think I have to do another one. None of these really give up anything here. I do like this. Someone came up with these questions. Go ahead. But the way I want to look at this is this. I'll grab another group here. Enter. And then I'll tell you something about the last thing that I'll give you time to write, but give you time to write this one too. Arrange the given numbers into a true logarithm equation. What I think you should do, and I don't know who came up with this, it's kind of cool, is put it truthfully in an exponent. So what group did I pick? I didn't even pay attention. Group 3. Hey, wait a minute. You didn't do anything. So you have to do 2 questions. Emily, first. All right. So what is true about 4 or 49, 2, and 7 as an exponential scenario with these 3 numbers? 7 squared equals 49. And now change this to a logarithm now. So what would this be as a logarithm? Base 7. That's how you say it. Of 49. That's how you say it. And then what? There you go. So what I think what's smart is, hey, take those numbers, put them what's true as an exponent, and then change it to a logarithm. Very simple thing. So someone came up with this. I don't know who did, and I like it. Ooh, nice. Trinity, before you go, what's true exponentially about -2, 6, and then 1 over 36? Okay, so I have to write it as an exponent. Some base raised to some power equals some answer. What would be true with these 3 numbers? Again, I'm telling you, this is why logarithms stink. People don't know their exponent rules. They can't memorize them. They can't memorize negative exponents. They can't memorize fractional exponents and what they mean. So what would be true? Yes? Equals. Now let's change it to a logarithm. Log, base what? Base is 6. And then of what? There you go. Equals what? -2. And then those kind of questions make you think about, those positions and so on and so forth. All right. And then at the end, I'll keep going. We have 5 minutes. She's got to go. But for the given data constructed, this is actually leading to something that they do with logarithms. So I do want to kind of cover it. And by the way, didn't I talk about it, the earthquake in Illinois not too long ago? Did I talk about that in this class? We had one. It was magnitude like 3 point something. But that's actually earthquakes is a logarithmic equation. It's actually an exponential scenario. So and they did have they're the coffee sippers. All right, I can't got to talk over them. So when a magnitude goes up to 4.3, 3.3 to 4.3, that's actually 10 times stronger than the previous. It goes by factors of 10 actually. So that's why a magnitude 7 earthquake is very damaging. 3.3, you might just feel it around the area. We didn't feel it up here when it was in central Illinois. I have in the past though. There was a larger one, um, actually within the time I was living in Manuka. So, but anyway, so here's how this works. This is kind of like a different scenario. This is base 2, not base 10. So this first tick mark right here represents 2 to the first. What's 2 to the first? 2. Then the second tick mark represents 2 to the second. What's 2 to the second? Then the next one is 2 to the third, 2 to the fourth, 2 to the fifth, and so on and so on and so forth. This is a way of, if you literally graph this out, 2, then 4 would be this far, then 8 would be way farther, and then 2 to the fourth is 16. Those would be really stretched out on the scale, but this is a way of putting them closer together so we can see the data on a little sheet like this. And then believe me, they do something like this later that we're going to have to learn, something that does a little bit more than this. So how do I graph this then? Bee population at their home, whatever. What's 2 to the first? 2. So 3 would be like right there. What's 2 to the second? 4. So 7 would be right here because it's close to 8. All right, do you get it? I mean, it's kind of pretty easy here. 2 to the fourth is 16. 2 to the fifth is 32. I guess I have to go to 2 to the sixth because then 38 would be a little bit after 32, which is what 2 to the fifth is, and so on and so on and so forth. All right. When you turn it into base 3, then this is 3 to the first, 3 to the second, 3 to the third. And you might want to get your calculator as these get larger. 3 to the fourth, though, is 81. So now, well, look at that. 3, Scarlet Witch is right on there. 3 to the second is 9. So 8 is now here. You can see how this is condensing this even more. If I did a Richter scale, this would be 10 to the first, 10 to the second, 10 to the third, right? And then that really shrinks down the x-axis so we could see the data points. I think that's good enough to understand what this means, but I will fill out this. 18, 3 squared is 9, 3 to the third is 27. So 18 would be like right around there. So on and so on and so forth. Okay, I think that's a decent end.